Firstly, marginal and total revenue, cost and profit. This key concept is associated with a specific change in the marginal use of goods and service. The total profit is the difference between the revenue received from the sale of an output and the cost of all inputs. In other words, the total profit is the difference between total revenue and total cost. Marginal profit is the profit that gained when one additional marginal unit is produced and sold. In other words, marginal profit is the difference between marginal revenue and marginal cost, where marginal revenue is the derivative of total revenue respective to the derivative quantity, while marginal cost is the derivative of total cost respective to the derivative quantity. Marginal profit also can be determined by derivative of total profit respective to the derivative of quantity. In the marginal profit function is given, the total profit can be determined by integrating the marginal profit function. Secondly is marginal and total supply. Based on the graph, we will describe the market supply. The market supply curve can be interpreted as the marginal cost curve for the market as a whole. The graph of the function typically drawn with the price on the vertical axis and the quantity on the horizontal axis is the market supply curve. As we discussed in the text, which is the market supply curve can be interpreted as the marginal cost curve for the market as a whole. It gives the minimum price at which sellers are willing to supply a given amount of the good. The marginal supply can be determined by the derivative of total supply respective to the derivative of quantity. The total supply can be obtained by integrating the marginal cost.
Now I would like to present the methods that is used to study the key concepts in the application of integration in economics. For the first key concept, which is marginal and total revenue, cost and profit, we use three methods which are normal integration, integration by parts, and also integration by substitution. Normal integration is used to determine the total profit, while integration by parts and integration by substitution are used to find the total profit from marginal profit. For our second key concept, which is marginal and total supply, we also use three methods, which are normal integration, integration by partial fractions, and also integration by substitution. These three methods are used in order to obtain the supply function from the marginal supply. Next, let's move on to the examples and analysis of the application of integration in economics. Let's see example 1. Our first example mirrors our first key concept, which is marginal and total revenue, cost and profit. So the question is, a firm determines that its marginal profit function is given by p prime x equals to 1000x squared exponent to the power of negative 0.2x. Find the total profit given that p equals to negative 6,000 ringgit when x equals to 0. Given that our marginal profit function is p prime x equals to 1000x squared exponential power of negative 0.2x, we have to find px, since we already know that when x equals to 0, px equals to negative 6000. The antiderivative of the function is shown as the following. So here we just simplify the function by taking out the constant, which is 1000. In order to integrate x squared exponential power of negative x over 5 dx, we have to use integration by substitution. As we can see in this integral, there's two different functions and there's also a derivative. So we use integration by substitution. So here we let u equals to 1 over 5x, and from there we find the value of x squared, and then we substitute the values into the function of px. After we substitute the value of u and x squared into the equation, we will have the following function. And then we use integration by parts to integrate u squared exponent power of negative u. Using the basic rules of integration by parts, we take m equals to u squared and dn equals to exponent power of negative u. And from there, we will get this equation. After applying integration by parts, we will get u exponent power of negative u. This integral is still unsolvable using normal integration, so therefore we have to reapply the integration by parts for the following function. So based on the basic properties of the integration by parts, we take m equals to u and dn equals to exponent power of negative u. And therefore, after some substitution, we will get the following equation. After substituting the value of u into px, we will get the following equation. So we just take out our constant, which is negative 5,000, so that we can calculate it easier later on. So we already know that when x is equals to 0, p equals to negative 6,000 ringgit. So what we do here is that we substitute the value of x in px with 0, and then finally we will get the value of constant c equals to 244,000. So therefore, for example 1, it can be concluded that px equals to negative 5,000 in bracket x squared plus 10x plus 50 exponent negative x over 5 plus 244,000. So in our example 2, we will reflect our second key concept, which is marginal and total supply. So the question here is, given s prime x equals to 100x divided by 20 minus x in bracket square, we have to find sx when the supply function S19 equals to 12,000. In order to get Sx, we have to integrate the value of S prime x. So here we just take out our constant, which is 100, and then we integrate the value of x divided by x minus 20 in bracket square. As we can see from this function, both the numerator and the denominator contain polynomials. Therefore, we use the method of integration by partial fractions to find its integral. After we remove all the denominators, we then compare the value of x and the value of the constant. And finally, we will get a equals to 1 and b equals to 20. So we just substitute the value of a and b into the partial fraction, and then we will get 1 over x minus 20 plus 20 over x minus 20 in bracket square. After we substitute the value of the partial fraction into the equation, the integration function will look like this. And since we cannot integrate 1 over x minus 20 in bracket square using normal integration, we have to use integration by substitution. So here, we let u equals to x minus 20 and du equals to dx. So after we substitute the value of x minus 20 with u, we will get the following equation. And so here we just substitute all of the values in, and therefore we will get Sx equals to 100 ln x minus 20 minus 20 over x minus 20 plus c. So since given in the question that S19 equals to 12,000, we just have to substitute all the values of x in the equation with 19, and we will get the value of our constant c equals to 10,000. Therefore, for example 2, we can conclude that Sx equals to 100 ln x minus 20 minus 20 divided by x minus 20 plus 10,000 is the required supply function.
As a conclusion, integration are widely used in economics. Integration method play an important in determining the output in the marketplace in order to achieve maximum profit and minimize the production cost. Marginal and total revenue are related to integration. If a marginal profit function is given, the total profit can also be obtained by integration marginal profit function. Total supply is related to integration. Total supply can be determined by integrating the marginal supply function. Various integration methods have been used to study the key concepts: normal integration, integration by substitution, integration by parts, and integration by partial fraction are conducted.